Welcome, everyone. I'm Gencler. I'm a technical specialist in the service executive team in InterSystems. Today, we'll be talking about encryption landscape for data at rest. We'll be taking an analytical approach to InterSystems IRIS encryption and how it interacts with storage reduction strategies. And we'll take a look at the storage level encryption and do a comparison. We'll start with first what encryption is and why we care. From there, we'll go into the 3 states of data and how to protect each. And then we'll start our deep dive into InterSystems IRIS encryption, do a quick overview of storage reduction strategies and storage level encryption strategies, and we will conclude with a comparison of encryption strategies with the context of storage reduction. Okay, first, what is encryption and why we care? Encryption is a mechanism, a process, that transforms data into ciphertext that is incomprehensible without first being decrypted. So now we know what it is, but why do we care? How does encryption help, and what does encryption help with? Since encryption turns data into incomprehensible text, it protects data from prying eyes. For example, if you have an email and it is encrypted, if the traffic gets intercepted, then the person who hacked your email, they won't be able to see the contents of that email. Or if you have a file and the file gets stolen, if it was encrypted, the people who stole your file, they won't be able to see what was in the file. In a spy movie, if you have a truck that is taking your tapes to the storage facility for archiving, if the tapes fall off the truck because somebody tampered with the door lock and put some plant bumps and a couple trips over there, and all your tapes fall off the truck, the thieves won't be able to see what was in your tapes. In a much less adventurous situation, you might care about encryption because of state rules, regulations, as well as federal rules and regulations such as HIPAA, GDPR, and also to gain consumer trust. Here we go. So let's get into the 3 states of data. We first have data in motion, which is also referred to as data in transit. This is data that is actively being transferred from one place to another. Examples include emails, download, HL7 messages being sent and received. And this type of data can be protected via SSL and TLS. Second, we have data in use. This is the data that is actively being accessed and is in memory. Since examples include data that is being read, updated, or deleted. Since this data that is in use, that is in memory, for it to be functional and useful, both for you and if somebody's trying to get their hands on this data, they wouldn't be able to make use of it if it's encrypted. So it needs to be decrypted when it's in memory. So the way to protect this type of data, this state of data, is through security setup. Third, we have data at rest. This is data that is stored on persistent storage devices or in the cloud. And an example for this state of data is an archive database in a storage facility. And to protect this state of data, we have InterSystems IRIS encryption and storage level encryption, which we'll get into momentarily. Do we have any questions so far? Okay. Let's move into our deep dive for InterSystems IRIS encryption. So at the bottom, we have acronyms that will just come up momentarily. So InterSystems IRIS provides a set of tools to manage and use data at rest encryption. And a key component of these tools is a key. A key is short for data encryption key. It is a 128, 196, or 256-bit string. And the key is used with a cryptographic algorithm. In case of InterSystems, this algorithm is AES, standing for Advanced Encryption Standard. Each key has a unique identifier called a GUID. And with this unique key identifier, the key management activities are done. A key is created by IRIS, and it is stored in a key file, unless you're using KMIP with HSM, in which case the KMIP server would create the key for you and store it for you. But again, we're not going to go into that presentation because Andreas already presented on that. And I also want to touch briefly on KMS. In a future release, we hope to provide support for KMS. In that case, the key structure would be a little bit different, but you still would have a key file. And again, Andreas has presented on that, so we're going to not go into that in this presentation. So we mentioned key files. Let's go back there. So key files are files. Each key file can contain up to 256 keys. And each key should have at least one administrator. And each administrator in the key file has access to all the keys in the key file. And key files are encrypted with key encryption keys. And this key encryption key is derived from the administrator's unique password. So every administrator has a unique copy of the key encryption key. There are two data encryption mechanisms provided by IRIS. One is database encryption, and the other one is data element encryption. Database encryption is also referred to as block-level database encryption. It is when all the data is encrypted at the block level. This includes on a system with database encryption, you can encrypt the databases, the journals, and the write-emit journal file, the WIJ. And within a database, all the data itself, indices, bitmaps, pointers, allocation maps, and incremental backup maps are all encrypted. One thing with database encryption that can be challenging is that it can't be done on the fly, which means that when you're doing the state of data transformation from unencrypted to encrypted, or vice versa, or when you're re-encrypting the database, then the data that you're trying to change the state of is inaccessible during that time. With data element encryption, we provide a programmatic interface that allows applications to include code for encrypting and decrypting individual data elements, such as particular class properties. And the great thing with data element encryption is that it can be done on the fly. So when you're changing the state of the data from encrypted to unencrypted, you can actually access that data and still make use of it. Another great thing with data element encryption is that it can be combined with database encryption, or it can be used separately on its own. And let's get into a little further details about data element encryption. So why would you want to use data element encryption if you can encrypt the whole database? And why would you want to use data element encryption if your database is already encrypted? Like, why would you want to add it on top of it, right? So you might have some sensitive data, such as credit card information, social security numbers, or you might have some VIP data in a hospital that has very high value in being exposed. So in those cases, you might want to use data element encryption for just those properties, or you might want to encrypt these information with data element encryption on top of database encryption, because you can do the on-the-fly encryption, and that would be very great if you have some re-encryption requirements, say, once a year. So your data would be available when you do so. Let's get into a quick comparison of data element encryption versus database encryption. So like we already talked about, database encryption can't be done on the fly, and data element encryption can be. The next is when the key is needed. For database encryption, the key is needed when you mount a database, which is usually at the startup. With data element encryption, the key is needed when the application user is interacting with the data element encrypted data. So from there, when is the key need to be activated? Because the key is needed at database mount time for database encryption, which usually is at startup like we said, we prompt at the startup of the instance for a database encryption key. But for whatever reason, if you don't need your database to be mounted at startup, you can always activate it later too. And similarly for data element encryption, you can activate the key with %zstart routine at startup, or you can do it later at runtime. In terms of interaction, that's a little different too. For database encryption, usually the interaction is done with the management portal or the CHUIs, caret database or caret encryption key, versus with the data element encryption, the interaction is usually through the API $system encryption, because it provides a programmatic interface. And another big difference is the maximum number of simultaneously activated keys. for database encryption is 256, versus for data element encryption is 4. So if you have a key file, say with 10 keys in it, and you want to use data element encryption, you will not be able to activate that key file. So on the other hand, though, if you have a key file with 3 keys in it, if you use data element encryption, you can activate all the keys in that key file, but afterwards, you can also individually deactivate the keys. I see some concerned faces. Are there any questions? Also, we're at the end of that topic. Before we get into operational aspects, are there any questions overall? Well, we have a silent audience. OK. One very interesting topic about encryption is performance. Since data is unencrypted once it's in memory, there is only a negligible amount of overhead for disk reads and writes. And in terms of the application, there's no noticeable performance impact. We're fast like a rabbit. In terms of how you get to start using encryption, there are 2 very straightforward cases. One is if you want to use data element encryption, since it can be done on the fly, it's pretty straightforward. The other very straightforward case is if you have no prior data and you just want to start off using encrypted databases, you just create a new encrypted database after you activate the key. Where it's a little bit more involved is if you already have a system with existing data and you want to use database encryption. First thing that we recommend that you do is you need to take a backup for just in case. And because encryption is done in place, if the process gets interrupted for whatever reason, the database will be left in a mixed state with half data being encrypted and half the data being unencrypted. So that database will be unusable. So you'll have to start the process over again with that backup that you took. And in terms of strategies, the first and most simple strategy is dismounting the database, which usually means that you might have some downtime. But this might not be a very realistic option for some applications that need to be running 24/7, 365. So for that, we have data move. With data move, you would create a new encrypted database, and you would move the data that you want, all or some of it, with data move to this new encrypted database. And in terms of data move, being able to do that, you would need enough storage on the server you're doing this. Another option is using mirroring. If you're using mirroring, you would make the encryption happen on the backup failover member, and the downtime would be equivalent to that of doing a failover. A key component. Oh, there's a question. Yes, Brad. Hold on. Could you?
If I understand going to encryption with mirroring, can you go the opposite direction to unencrypt?
Yes, you can absolutely go the other way as well. It's the same process, and it's, again, the same considerations. Like if you're trying to unencrypt, you also would want to take a backup, because if you're in the mid-process of unencrypting and then something interrupts your process, your database would be half-half. Huh?
So it's still scary.
It could be. If you have a backup, it shouldn't be.
From an earlier slide, I understand that you can re-encrypt encrypted data.
Yes,
If
correct.
you were to go from unencrypted to double encryption, does that also involve 2 periods of downtime or data moves?
So if you're re-encrypting database encryption, yes, anytime that you do a re-encryption, the data would be unavailable for database encryption. That is why data element encryption is so cool, because it can be done on the fly, so you would not need any downtime for that.
I see. Thank you.
Does that answer? OK. Awesome. Anybody else? I love questions, so. No? OK. So going back to key management, key management is a set of activities that are associated with creating, activating, deactivating the keys, as well as protecting, storing, and managing authorization of keys. And key management is very important to ensure encryption can and do provide the intended protection. Without proper key management, benefits of encryption could be negated, or worse, all data can be lost or used for non-intended purposes. I'm going to pause here for just a brief second so that everybody can internalize this, because this is important. OK. If you lose the key, you lose the data. There are no backdoors. So the key is not losing the key. So how do we avoid losing the key? Here are some general guidance that we'll get into. But before that, it is the customer's responsibility to prepare an encryption key management plan that follows the customer's particular needs and requirements and to adhere to it. So there have been some situations where there's a plan that's created, but then is not adhered to, and there's no value in that really. So let's get into some general guidance. First is what we have is online backups. With online backups, they are not encrypted, so you would want to use a different mechanism to protect that if you're using online backups. The other thing is if you have multiple keys, we recommend that for multiple database encryption keys, we recommend that you put them in a single key file. And this is because if you're starting up an instance, like I mentioned before in a previous slide, we'll prompt you for the database encryption key. If you have them all in one single key file, you'll be able to specify that key, and your instance will start on its own pretty easily. And here, 256 is the magic number, because 256 is how many keys you can have in a key file, as well as the maximum number of database encryption keys that can be simultaneously be activated. And from there, let's go into the maximum data element keys that can be activated simultaneously. It's 4, right? So that means that if you want to use data element encryption and database encryption, it is probably a good idea to separate the key files for each so that you can activate your data element encryption keys. The other reason you might want to separate the data element encryption keys is within themselves is because if you have such as like information like HIV versus credit card information that are completely two different applications, the keys might not need to be activated at the same time. And you also might not have the same administrator for those key files. Another important thing to consider is the key location. So if you have an unexpected downtime, time is of the essence. So you would want the operational key to be in a close by vault so that if there's something that happens and you need the key, you have very easy, quick access to it. On the other hand, if there's an earthquake or a fire, some kind of disaster happens, you also would want a copy of this key in a safe, secure location in a distant place. And we also recommend that you have at least 2 people who have access to the key, such as 2 security guards and 2 separate people who have authentication to the key, like 2 DBAs. And the reasoning behind that is at one time, you would have 2 people so that one doesn't walk away with the key. And the other is because if somebody decides to take a month-long PTO, you have a backup. And the other thing is if that person who decides to take a month-long PTO forgets the credentials, what happens then? If everybody forgets their credentials to the key, you won't be able. Hi, go ahead.
Do I understand this right? You're saying you have someone who has access to the key, like I can go get the USB stick that has the file on it.
Exactly.
And somebody else who has the password.
Exactly, yep.
Okay.
Yeah, somebody who has access to the physical key vault with the USB-C stick or whatever device that you're storing the key file in it. And somebody completely different who has actually the password to get into the key file to see the GUID for the key. Yeah. Does that make sense? Yeah, okay, cool. And again, going back to the PTO, it's nice to be in Florida and think of vacation. So if the administrators all forget their passwords, it's good to have a distant vault again where you have a set of credentials or more just in case. Because again, if you can't access the key, then you can't activate it to decrypt your databases. And in terms of how much effort and thinking goes into this key management, we first recommend that you use HSM with KMIP because it takes care of it for you, quite a bit of this. Second, we recommend that you use KMS when the support is there, with a copy of the key file, again, in a distant vault. And last but not least, we recommend using the key file option. Okay, are there any questions before we move on?
Yeah, just a question. You said multiple keys. is it working for one instance IRIS? You can have multiple keys, or you can have a key, for example, for a namespace.
You can have multiple keys per instance, as long as you have maximum of 256 keys in a key file, but you can have multiple key files. Again, the other thing is like you can have at most 4 keys activated for the data element encryption.
Yeah.
So.
Okay, because I implement else data lake using IRIS, and in the documentation it says 4 keys for data elements and only 1 key for the instance. Okay.
It's outdated information.
Oh, outdated information.
Okay.
This is outdated information.
You were not incorrect, but we just changed.
Okay, so I'll talk about it after.
Are there any other questions? Okay. So let's briefly touch upon storage reduction strategies. Since storage is one of the more expensive hardware resources, there are a multitude of options available from respective storage vendors on assisting with physical disk space usage. One of those strategies is deduplication, which is elimination of extra copies of data, and the other one is compression, the reduction in number of bits needed to represent data. And storage level encryption strategies are array-based encryption, where the disk controller encrypts the data before it is sent to disk drives, and file system level encryption, where the file system encrypts individual files or directories. For array-based encryption, and we're now at the comparison stage, are there any questions regarding those 2 slides? Okay, this is the fun one. So for array-based encryption, the encryption is done after the data reduction actions. So that means that with array-based encryption, you gain both the storage efficiency from compression and deduplication, as well as the protection from the data encryption. And indeed, with array-based encryption, you have the highest yield of data reduction. Additionally, if you're using mirroring, it deduplicates really well between database mirror volumes. On the other hand, with array-based encryption, you are protected against theft of physical device, but not against theft of file. And this is very similar to file system level encryption, where you are, again, protected against the physical device theft, but not the file theft. Additionally, if you're using file system level encryption, performance will vary. So we highly recommend that you test it on your individual system first. With InterSystems IRIS encryption, we protect against both. So that is great. On the other hand, with InterSystems IRIS encryption, encryption is done first before the deduplication and compression operations. So it has the lowest level of data reduction. And we mentioned theft of file, so let's get into that real quickly too. Cloud-based solutions in a fortified data center is where you would be concerned mostly with the theft of file, especially if Tom Cruise is involved. Theft of device is a bigger concern for servers that are located on-prem with many people who have access to it. On the other hand, in an age of multi-disk arrays, it is a much smaller problem because you can't slip a whole server rack into your pocket and walk away. And before we wrap up, are there any other questions? Hi, Chad.
Hello. Is there any cloud vendor that offers that array-type deduplication and compression services? I haven't seen one. I just wonder if you knew of one.
I am not sure.
So that's mostly just for on-prem, where you can you have your own storage array and you can configure it the way you want to.
Say it one more time.
So the array-based compression and dedupe, that's only available for like on-prem customers.
I don't know. That would be a good question, I think, for Mark Belinsky.
We should summon him.
Yeah. Sorry.
No worries.
Are there any other questions? Okay, let's wrap up. So we talked about the 3 states of data and how to protect each. We had data in motion, also called data in transit. We have data in use, and we have data at rest. And for data in motion, you could protect it with SSL TLS. Data in use could be protected with security settings. And for data at rest, we have InterSystems IRIS encryption and storage level encryption. And in terms of InterSystems IRIS encryption, again, you have the database encryption or data element encryption. And for storage level encryption, you have the array-based encryption or the file system level encryption. And key management is very important, and it takes a certain level of nurturing. And each strategy has its own advantages and disadvantages. With array-based encryption, you will have the highest yield of data reduction, but you will not have any protection for theft of file. With InterSystems IRIS encryption, you will be protected against theft of file as long as you're not using unattended key activation where it would put everything in the same place. But you would also have the lowest level of storage reduction. In terms of InterSystems IRIS data element encryption, it is great if you have particular properties. Was there a question? No? Okay. If you have particular sensitive data, for example, like class properties, credit cards, SSN, or VIP data, it is great for encrypting those programmatically. Additionally, strategies can be combined or used individually, but if you combine them, you might be paying double the penalty. So next steps are we have a documentation link. It's actually really good, the encryption guide. We had a presentation by Andreas Dikov, and if you haven't had a chance to attend them, there will be a recording made available later on. Tech Exchange is a very good place as well to get further questions answered. And you can always email me, Andreas, and Mark Belinsky. And our emails are pretty easy too. Mine is john@intersystems.com, if you spell it correctly. Andreas is at andreas@intersystems.com, and Mark Belinsky as Belinsky@intersystems.com. Thank you very much. Are there any other questions? Okay.